Welcome back to lesson 10, and we are going to solve these 11 problems. Let's go to the first one. Okay, the chain rule is based on the following idea. Well, let me explain first. This is the function u of x. So it transforms the value of x into another value u of x. Maybe u of x is 3x. So if x equal 1, the u is 3. Or maybe if x equal 2, the u is 6. So there is a u of x here. And now there is a function f of u that takes the value u. If x equal 1, u equal 3. So the f takes the value 3 and transform into another value. Maybe 2. 2 by 3, 6. So you take this value, let's go to put the values. If u of x is 3x and f of u is 2u. So I start with the number 1. So u of x transform it into a 3. And now f of u is transforming the 3 into a 6. Okay, if this idea is clear, this is f of 3, f of u, and this is u of 1. u of 1 transforming 3, u of 3, f of 3 transforming 6. And the question is, at what speed? Here there is a speed, so let's go to do it. This is the x, and this is the u. The u, there is a speed here. The derivative of u respect to the x. There is a slope. And here, f of u, there is another slope. The derivative of f respect to the u. So the question is, here is f. The question is, how is the change of f respect to the x? Well, what it said the chain rule, that the chain of f respect to the x is the product of these two chains, the chain in u respect to the x plus the chain in f respect to the u. So it's the chain in f respect to the u multiplied by the change in u respect to the x. So if you want to think in this way, you may think, for example, if you move things from here to here 3 times faster, from here to here you move 2 times factors. From here to here you are moving 6 times faster. This is the way that you can think about the chain rule. Okay, let's go to, or maybe you can do this problem and we can check. We can check, for example, with this problem. If u of x is 3x, and f of u is 2u, what is f of u? F of u is 2u. And what is u? U is 3x. And what is 3 multiplied by 3x is 6x. And so f of x is 6x. And what is the derivative of f respect to the x? Is 6. Now let's go to check. The derivative of f respect to the x is the derivative of f respect to the u multiplied by the derivative of u respect to the x. What is the derivative of u respect to the x? The derivative of u respect to the x is 3. What is the derivative of f respect to the u? The derivative of f respect to the u is 2. So the derivative of f respect to the u, 2. 2 multiplied by the derivative of u with respect to the x, 3, equals 6. So we have the same result. Okay, now we go to do more problems. Welcome back, and let's go to do problem number 1. To do problem number 1, we do it like this. We name u like 4x minus 1. Now this is u of x. U depends on x, and is 4x minus 1. And what is the derivative of u respect to the x? The derivative of u respect to the x is 4. Now we apply the chain rule. The chain rule says that the derivative of f respect to the x equal the derivative of f respect to the u multiplied by the derivative of u respect to the x. Now, f of x, f of u will be 4x minus 1 is u, so f of u will be u cubed. What is the derivative of f respect to the u? Is 3u squared. Oh, so I have the two pieces. To find the derivative of f respect to the x, I will do the derivative of f respect to the u, 3u squared. And I will multiply by the derivative of u respect to the x, 4, equal 12u squared, and the problem is solved. So what we are doing is like this. You have u, you have x, you have u of x, and you have f of u. So you take the point 1. So u of 1 will be 4 multiplied by x minus 1. It will be 3. And f of 3 will be the cubic root of 3, a square root of 3. Now, when you move here, what is the derivative of f respect to the x? This is the x here, the x, the u, and the f. What is the derivative of f respect to the u? Is the derivative of u respect to the x. The derivative of u respect to the x multiply by the derivative of f respect to the u. Multiply by the derivative of f respect to the u. So it's the product. The variation of the function f respect to the x is the product of the variation of f respect to the u multiplied by the variation of u respect to the x. So let's go to apply this equation once and again 11 times. Okay, next problem. But before, let me tell you that the solution that I give you is incomplete. It should be 12 times here, 12 times u, but u squared. U is 4x minus 1. 4x minus 1 squared. U squared. So this is the final result. Okay. Use the chain rule to find the derivative square root of 5 minus t. What you will do? You will say like this. If I name u equal 5 minus t, I know that the derivative of u respect to the t will be 5, will be minus 1. So, f of u will be a square root of 5 minus t, square root of u. So it will be u 1/2. And the derivative of f respect to the u, it will be 1/2 u 1/2 minus 1 minus 1/2. So what is the derivative of f respect to the x? Is the derivative of f respect to the u multiplied by the derivative of u respect to the x. Putting all the pieces together, the derivative of f respect to the u is 1/2 1 divided by a square root of u, because this is 1/2 1 divided by a square root of u, multiply by the derivative of u respect to, well, this is respect to t, sorry. Let me write again. The derivative of f respect to the t is the derivative of f respect to the u multiplied by the derivative of u respect to the t. This is, so let me correct here. Yeah, it's already correct. So the derivative of f respect to the u, we said that is 1/2 1 divided by a square root of u. And the derivative of u respect to the t is minus 1. So the final result will be minus 1 divided by 2 times 1, 1/2. Or minus 1 divided by 2 times the square root of u. And this is the final answer, no, because u is 5 minus t. So it will be minus 1 divided by 2 square root of 5 minus t. And this is the final answer. And this is the derivative of f respect to the t. This problem say, use the chain rule to find the derivative of cosine of 4x. So we name u as 4x. So we have f of u equal cosine of 4x cosine of u. What is the derivative of u respect to the x? Is 4. What is the derivative of f respect to the u? Is the derivative of cosine is minus sine of u. So what is, now we take our chain rule. It says the derivative of f respect to the x is the derivative of f respect to the u multiplied by the derivative of u respect to the x. Okay, what is the derivative of f respect to the u? Minus sine of u. What is the derivative of u respect to the x? 4. Is already finished the problem? No. Now I have to write what is u. U is 4x. So it's minus sine of 4x multiplied by 4, so I can put it in front. Minus 4 times sine of 4x. This is the final result. Let's go to another problem. Use the chain rule to find the derivative of 5 tangent of 3x. We'll do the same thing. We'll do u will be 3x. The derivative of u respect to the x will be 3. And f of u will be 5 times tangent of u, of 3x of u. So what is the derivative of f respect to the u? Well, the derivative of tangent of u is secant square of u. So it will be 5 times secant square of u, because the derivative of tangent is secant square. So now we write our equation that say that the derivative of f respect to the x equal the derivative of f respect to the u multiplied by the derivative of u respect to the x. What is the derivative of f respect to the u? Is 5 times secant square of u multiplied by the derivative of u respect to the x. The derivative of u respect to the x is 3. So it will be 15. It will be 15 times secant square of u. And is the problem already solved? Is this the final answer? No. It's 15 times secant square of u of 3x. And this is now the final answer. So this is the derivative of f respect to the x. This is the slope of the function. 5 times tangent of 3x. At the point x, you plug in the point and you obtain the derivative, the slope. Let's go to the next problem. Find the equation of the tangent line to the graph f of x equal 9 minus x squared. So we name u, because to find the slope, to find the tangent line, we need the slope. So we name u like 9 minus x squared. So the derivative of u respect to the x is minus 2 times x. Minus 2 times x, because the derivative of 9 is 0, because 9 is a constant function. So it never changes. So the variation, the slope is 0. So f of u f of u will be 9 minus x squared u raised to the power 2/3. And the derivative of f respect to the u will be 2/3 multiplied by u. 2/3 minus 1/3 is 2/3 minus 3/3. 2/3 minus 3/3 is minus 1/3. Or 2/3 cubic root of u. So now we write our equation that say that the derivative of f respect to the x is the derivative of f respect to the u multiplied by the derivative of u respect to the x. What is the derivative of f respect to the u? Is 2/3. 2 divided by 3 times cubic root of u. And what is the derivative of u respect to the x? Is minus 2x. So doing a little bit of algebra will be minus 4x in the numerator and 3 times the cubic root of u. But u is 9 minus x squared. And now this is the final answer. Okay, let me put this 3 correctly. 3 times. Okay, let's go to the next problem. And no, to the next problem. And the next problem, and say, find the equation, and at the point 1,4, what is the slope? The slope at the point x equal 1, if x equal 1, I have to be sure that they are not cheating me. If x equal 1, will be 9 minus 1, it will be 8. 8 squared will be 64. And the cubic root of 64 will be 4 according to this. 4 by 4, 16, 16 by 4, 16 by 4, 16 by 4, 16 by 4 is 24, 4 is 64, so it's correct, it's 64. They are not cheating. So what is the derivative of f respect to the x evaluate at x equal 1? Well, the derivative of f respect to the x evaluate at x equal 1 will be minus 4 divided by 3 times cubic root of 9 minus 1, which is 8. The cubic root of 8 is 2 by 2 by 2 is 8, is 2. So it's minus 4 divided by 3 multiplied by 2, or minus 4 divided by 6, or minus 2/3, minus 2/3. And what is the equation of the tangent line? Is the equation y equal y0 plus m multiplied by x minus x0, where the point P is the point 1,4, I think, 1,4. 1,4. So this is the x0, this is the y0. So the equation of the tangent line, it will be 4 plus m minus 2/3 multiplied by x minus x0 minus 1. Of course, that I can do a little bit of algebra here, and with it will be y equal 4 minus 2/3 times x plus 2/3. And now I can add y equal 4 minus 4 plus 2/3 minus 2/3 of x. And the final result will be y equal minus 2/3 of x plus 4 plus 2/3 is the same like 12/3, which is 4 plus 2/3. So it's 14/3. 14/3. And this is the final result. This is the equation of the tangent line that passed through the point 1,4 and is tangent to the line. Is tangent to the curve. It kisses the curve only in one point. What point? The point 1, 4. Now we are going to do the following problem. Problem 6, say find the derivative of the function 26 minus secant cube of 4x. The derivative of 26 is 0 because it's a constant function. So we need to find the derivative of minus secant cube of 4x. This is the way that you can do it very fast. Put the 3 going down here, minus 3. Take 1 power less, will be secant square of 4x. Make the derivative of secant x with secant 4x, which is secant 4x multiplied by tangent of 4x. And multiply this by the derivative of 4x, which is 4. And you will obtain minus 12 secant cube, secant square multiplied by secant square 4x multiplied by secant 4x is secant cube of 4x multiplied by tangent of x. Okay, let's go to do it not so fast, but using the chain rule. So we name the function that we have is f of x equal 26 minus secant cube 4x. So we name u secant 4x. If u is secant 4x, the derivative of u respect to the x, it will be the derivative of secant is secant tangent. So it will be secant tangent, secant of 4x multiplied by tangent of 4x. And this I have to multiply by the derivative of 4x, which is 4. So it will be 4 times secant 4x multiplied by tangent of 4x. What is f of u? F of u is 26 minus u cubed, because u is sine of 4x. So what will be the derivative of f with respect to the u? The derivative of x with respect to the u will be the derivative of 26 is 0, and the derivative of u cubed, the power rule, will say that is 3 times u, 3 minus 1, u squared. Okay, so I apply my equation for the chain rule. The derivative of f with respect to the x is the derivative of f with respect to the u multiplied by the derivative of u with respect to the x. What is the derivative of f with respect to the u? Is here. Is here, minus 3 times u squared, minus 3 times. What is the derivative of u with respect to the x? The derivative of u with respect to the x is here, so it's all here. So I do a little bit of algebra. 4 by 3 is 12. It would be minus 12. And now I substitute u by his value, secant. So it would be secant square of 4x. Secant 4x multiplied by tangent of 4x. Secant square multiplied by secant is secant cube 4x multiplied by tangent 4x. So the final result is minus 12 secant cube 4x tangent of 4x, which is exactly the same that I did. Maybe this method is also okay. But sorry, I didn't finish to do the problem. The problem say to find the tangent line to the curve at the point 0, 25. I will make sure that the point 0, 25 is on the graph. Let's go to see what is this. When x is 0, sine of when x is 0, y should be 25. So if I go to the equation is this equation 26 minus when x is 0, sine cube of 4x, sine cube of 0, or secant of 0 is what? Secant of 0 is 1 divided by cosine of 0. Cosine of 0 is 1. 1 divided by 1 is 1. So 26 minus 1 cube minus secant cube of x of 4x is 25. So it's correct. So this is the point. And what I have now is that this equation allows me to find the slope at the point x equals 0. What is the slope? the derivative of the function respect to the x, the slope, at the point x equals 0 will be minus 12 secant cube of 4 by 0, 0, multiplied by tangent of 0. Tangent of 4 by 0 is 0. Now, this is minus 12, secant cube of 0 is 1, because it's 1 divided by cosine cube of 0. Cosine of 0 is 1, 1 divided by cosine cube of 0 is 1. Multiplied by tangent of 0 is 0, so this will be 0. So it means that the slope is an horizontal slope. So what is the graph? The graph is y equal y1, this is x1, this is y1. Y equal y1, y1 is 25, plus the slope is 0. So the line is y equal 25, this is 25, and the slope at the point x equals 0 does like this. So the curve should do something like this, with a slope horizontal. So the final answer is y25, y equal 25. You see, y is 25 for L or x. Y equal 25, this rectilinear line with a slope 0, this is the slope, is a line that is tangent to the curve. To what curve? To this curve, 26 minus secant cube of 4x. Okay, the next one, find the derivative of tangent, sine of tangent of 2x. So u is tangent of 2x. And the derivative of u respect to the x is the derivative of tangent of 2x. The derivative of tangent of x is secant square of x. So it's secant square of 2x, but multiplied by 2 by the derivative of 2x. So this is the derivative of u respect to the x. So what is the function f of u? F of u is sine of tangent of x, sine of u. What is the derivative of f respect to the u? The derivative of f respect to the u is cosine of u. So we apply our power rule that say that the derivative of f respect to the x equal the derivative of f respect to the u multiply by the derivative of u respect to the x. We plug in our result the derivative of f respect to the u, cosine of u. But what is u? U is tangent of 2x. So it will be cosine of u, of tangent of 2x, multiplied by the derivative of u respect to the x, multiplied by secant square of 2x multiplied by 2. And this is the final result. Okay, next problem is find the derivative of 3x minus 1 squared divided by x squared plus 3. How we will do this without not doing a lot of algebra? If we call u, if we name u as 3x minus 1 divided by x squared plus 3, I can get the derivative of u respect to the x. What is the derivative of u respect to the x? The derivative of the numerator multiplied by the denominator x squared plus 3 minus the numerator 3x minus 1 multiplied by the derivative of the denominator 2x, and everything divided by the denominator square. So what I'm applying is the quotient rule. The quotient rule say that the derivative of a fraction is the derivative of the numerator, which is 3, multiplied by the denominator, minus the derivative of the denominator, 2x, multiplied by the numerator, 3x minus 1, divided by the denominator square. So I can make a little bit of algebra here. It will be 3x squared plus 9 minus 6x squared minus 6x squared plus 6x plus 2x divided by x squared plus 3 squared. So it will be 3 squared minus 6 squared is minus 3x squared plus 2x plus 9 divided by x squared plus 3 squared. So I have the derivative of u respect to the x. Now I have f of u. F of u is u squared because u is 3x minus 1. So the derivative of f respect to the u, it will be 2 times u. So what will be the derivative of f respect to the x? Well, the chain rules say that the derivative of f respect to the x is the derivative of f respect to the u multiplied by the derivative of u respect to the x. What is the derivative of f respect to the u? The derivative of f respect to the u is 2 times u, but u is 3x minus 1 divided by x squared plus 3. Okay. 2 times multiply by the derivative of u respect to the x. The derivative of u respect to the x is minus 3x squared plus 2x plus 9 divided by x squared plus 3 squared. So you need to do a little bit of algebra. In the denominator will appear x squared plus 3 cubed, and in the numerator you have to make the multiplication. Let's go to the next problem. Now let's go to do problem 9. It's find the derivative of the function f of x. Let's go to do it very, very fast. F of x is 5 times x cubed minus 2. What is f prime of x? The slope at any point x, the derivative. And this is x cubed minus 1. It will be minus 5 x cubed minus 2 raised to the power minus 1 minus 2 multiplied by the derivative of u of the internal function, which is 3x squared. So the solution will be minus 15x squared divided by x cubed minus 2 squared. And at the point x equal minus 2, f prime evaluate at the point minus 2, so the slope that exists at the point minus 2 of this function, the slope is minus 15 minus 2 squared divided by minus 2 cubed minus 2 squared. And doing the numbers, minus 2 squared is 4. 15 by 4 is 16, and the sign will be minus 16. And in the denominator will be minus 2 cubed is negative, and is minus 8. Minus 8 minus 2 is minus 10. Minus 10 squared is 100, positive. So this will be minus 6 divided by 10. So this is the slope at the point, or if you prefer, minus 3/5. This is the slope at the point x equal minus 2, and the problem is solved. Well, problem 10 is this one. We'll write the equation. To do it quickly, we'll write the equation like this: 4 times x plus 2 raised to the power minus 3. So the derivative of f with respect to the x, we can do it very fast. Minus 3 multiplied by 4 is minus 12. X plus 2 minus 3 minus 1 is minus 4. So the derivative is minus 12 divided by x plus 2 raised to the power 4. And the problem is solved. But the problem, is asking by the second derivative. So I have the first derivative, f prime of x. F prime of x equal minus 12 divided by x plus 2 raised to the power 4. Or, in other words, I have minus 12, let me put it here, minus 12 x plus 2 raised to the power minus 4. And now what I want now is f second of x, the second derivative. The second derivative means do again the derivative of f prime, and you will obtain the second derivative. What is the meaning of the second derivative? The first derivative is the slope, is the change in y when x vary, is the slope. And the second derivative is the change in that slope. The second derivative is the change in the slope when x change. So a curve will have a slope. This one is the slope. Let's go to put it. This one is the slope. This one is one slope. And when you move a little distance x, delta x, when you move to x plus delta x, the slope for sure will change. So the slope here maybe is 1. And maybe here the slope will change to 1.1. So the second derivative measure what is the change in the slope. So from 1 to 1.1 slope, the change in the slope. And the problem is say, what is the change of the slope? Or what is the f second? The recording stopped, so I will say what I did. The first thing that I will do is, let's say that I make a little bit of algebra here, and I know that tangent square of x is secant square of x minus cosine of square of x minus secant square of x, that is 1 divided by cosine square of x. If I make the subtraction of these two fractions, will be sine square of x minus 1 divided by cosine square of x, because they have the same denominator. Now, sine square of x minus 1 by the trigonometric identity is cosine square of x. So this will be cosine square of x divided by cosine square of x, so it will be 1. What it says that the function f of x is the function 1, is the function that never change, is the function that have a slope 0. So the derivative, that is the slope, should be 0. So we have to do the mechanical way to find the derivative and to show that this is 0. But for sure we could stop here and say that because this is 1, the derivative of the constant function is 0. A constant function has a slope 0. And let's go to do it. Let's say that we didn't realize of these facts and we want to do it. What is the derivative of tangent square of x? What is the derivative of tangent square of x? Is 2 times tangent of x multiplied by the derivative of tangent of x. The derivative of tangent of x is secant square of x. What is the derivative of secant square of x? The derivative of secant square is 2 times secant of x multiplied by the derivative of secant of x. And the derivative of secant of x is secant tangent. Perfect. So because this is equal this, you see that this is equal this is the same number here than here for any x. The difference should be 0. So we have proved that the derivative is 0. So the problem is solved. So good luck, and I hope you will enjoy this video. Thank you. These are practice problems. You don't have to do it if you don't want, but if you want to practice, you can do it. For example, we can do problem 12. Problem 12 say like this. Y is u squared, and u is 1 divided by x minus 1. Perfect. So I want to know the derivative of y respect to the x. The derivative of y respect to the x is the derivative of y respect to the u multiplied by the derivative of u respect to the x. Well, what is the derivative of y respect to the u? Is 2u. What is the derivative of u respect to the x? Well, this is x minus 1 to the power minus 1. So it's minus x minus 1 minus 2 is the derivative. So plugging the numbers, we will have that the derivative of y respect to the x is the derivative of y respect to the u, 2u. The derivative of u respect to the x is minus x minus 1 minus 2. We can plug in what is u, it will be minus 2 divided by x minus 1 multiplied by 1 x minus 1 squared, or minus 2 divided by x minus 1 to the cube. There is any way to check this result directly? Yes, very easy. If y is equal u squared and u is 1 divided by x minus 1, so y is 1 divided by x minus 1 squared. So I will make the derivative here. The derivative of y respect to the x is the derivative of 1 divided by x minus 1 multiplied by 1 divided by x minus 1. So it's a product. How we will do the product is the derivative respect to the x of this product. How we will do the part, this derivative is the derivative of the product. Let me put here a parenthesis like this, is the product of two functions. So it's the derivative of the first multiplied by the second plus the derivative of the second multiplied by the first. What is the derivative of the first? The first is x minus 1 raised to the power minus 1. What is the derivative? The derivative is minus 1 multiplied by x minus 1 to the power minus 2 multiplied by the first x minus 1. And now the same result will appear. So I will put a 2 here. Well, let's go to do it if you want. Plus the first is x minus 1 by the derivative of the second. But the derivative of the second is minus 1 by x minus 1 minus 2. So you see that it will be this, and this is the same, so it will be minus 2 times 1 divided by x minus 1 squared multiplied by x minus 1. So it will be minus 2 times x minus 1 cubed. Let's go to check if it's the same. Oh, yes, it's the same. Okay, you don't need to do these problems. These are the same problems. You can do it if you want. These are the same problem. Very easy problems to do. When you know how to do the 10 problems, you know how to do any problems. Okay, and this one of compound interest, we will do it later. Compound interest and depreciation, we will do it in another video. Okay, ready.